Hey everybody, welcome to Chem. We're going to do a quick practice problem using the ideal gas law. Let's see what it says. Dinitrogen oxide, N2O, which is used in dentistry, is an anesthetic, also called laughing gas. What is the pressure in atmospheres of 0.350 moles of N2O at 22 degrees Celsius in a 5-liter container? First thing we have to pay attention to is they gave us Celsius, and we cannot use Celsius when we are calculating using the ideal gas law formula. So the first thing we have to do is get rid of this and change it into Kelvin. So the formula to do that is Kelvin equals degrees Celsius plus 273. So all you have to do is sub in that degrees Celsius in the formula, add 273, and you'll be good to go. When you do that, you will see that Kelvin equals 22 degrees Celsius plus 273. Add that up in your calculator, you will get 295 Kelvin. If you mistakenly put degrees Celsius inside your ideal gas law formula, unfortunately, you will get it wrong no matter what you do. I always recommend writing out your variables off to the side so we can see what we're solving for and make sure that all of our units are appropriate for the ideal gas law formula. So here we go. The ideal gas law formula is PV equals nRT. Okay, so I'm going to write them all out off the side here. P, E, N, R, and T. Now, if we reread that second sentence, it says, what is the pressure in atmosphere? So I'm just going to put a question mark by pressure just to remind myself that that's what I'm trying to find. I have 0.350 moles of N2O. Moles is your N value. The 22 degrees Celsius, we changed it into Kelvin, and that's your temperature. So 295 K goes down here. And 5 liters is what's your volume. Put that right here. Now that R value, you have two options for an R value, and those are the gas constant. You want to choose the one that contains atmosphere. So one contains atmospheres, one contains millimeters of mercury. It's super important that you choose the one that contains atmospheres. And that number is 0.0821 with all these units. Liters times atmospheres over moles times Kelvin. Now, an easy way to check yourself before you wreck yourself here, make sure all of your units match that gas constant. It contains liters, atmospheres, moles, and Kelvin, and that's what you currently have. So far, you're on the right path to getting the problem correct. So now let's sub everything into our formula. Our P value, we're just going to put P there because that's what we're trying to find. Volume is 5 liters equals our N value, which is 0.350 moles. Our R value, which is 0.0821, and then all those units, liters times atmospheres over moles times Kelvin, and then our temperature, which is 295. Okay. I don't like to put too many numbers in the calculator at the same time. So what I would recommend doing is rewriting this line and cleaning up the right side. So we'll write P, and then we'll write 5 liters again. And then what you want to do is multiply those three numbers in your calculator. So 0.350 times 0.0821 times 295. And you will get 8.477. Now, when you multiply these numbers together, some of these units are going to cancel. So these moles are going to cancel. These Kelvin are going to cancel. And the units that are left over right now are liters and atmospheres. Okay? Now, I want to get P by itself. Should have highlighted it so we don't lose it here. In order to do that, I have to divide 5 liters on both sides. Okay? When something is divided by itself, it's going to cancel. And if you watch these liters, because they're in a numerator and a denominator, they're going to cancel. And it makes sense that you're going to end up with atmospheres as the unit that is in your answer because you're solving for pressure. So I'm going to bring down that P there. And then when you take 8.477 divided by 5 in your calculator, you'll get 1.69 ATM.